Alright, so it tells us if cosine of theta is 5/8 and theta is in quadrant 4, find each function value. Remember a long time ago you used to take this and you used to say this is x over r, and then you would draw a triangle and you would say the x value was 5 and the radius was 8, and then you use Pythagorean theorem and you can find all 6 trig functions. But we're not going to be drawing pictures anymore. We're going to be using identities. On your formula sheet, look where there is a identity that has cosine and sine on it. Put your finger on it. Now, some of you may have put your finger on tangent. Raise your hand if you put yourself on tangent. Okay. Now, the reason why I can't use tangent is because cosine I have, but sine is an unknown and tangent is unknown. So if you have two unknowns, you would have to use a systems of equations, two different variables. Okay. So the one that you should put your finger on is the Pythagorean identity. Raise your hand if you put it in the Pythagorean identity box. Class, what identity are we going to use? Sine squared theta square theta equals 1. Now you guys took notes that the power of 2 here is a little bit weird. Normally we write x squared and then the exponent is in the top right. Yes? But for trig functions you have the variable and the power of 2 is over here, so you can rewrite the problem. Sine theta squared plus cosine theta squared equals 1. Now I'm just going to do a substitution. Cosine is equal to 5/8. So I have sine theta squared plus 5/8 is my substitution, squared equals 1. So essentially that just means 5/8 times 5/8, which is how much, class? 25 over 64. Now look ahead. You're eventually going to have to subtract this from both sides, right? So I'm going to make this a common denominator of 64. I'm changing this 1 to be 64 over 64. Here's the reason why. If I subtract both sides now with minus 25 over 64, do you see how this was easier? Instead of saying 1 minus 25 over 64, that's essentially 64 minus 25. So I have sine of theta squared equals 64 minus 25. I get 39 over 64. To get rid of the power of 2, I'm going to take the square root. Sine of theta equals plus or minus. Now when you have a fraction, you're just taking the square root of 39, which you cannot find. And then you have the square root of, pay attention, 1 over 64. Class, what is the square root of 64? So really the square root of 1 over 64 is 1 over 8. 8 is in the denominator. Now you might be asking, Mr. Ng, you have two solutions here. Which one do I pick? Well, if you go back to your clue, it tells you, and theta is in quadrant 4. Well, I know an acronym. What acronym do we know, class? And we're in quadrant 4. So that means only cosine and secant are positive. Everything else is negative. So our answer is sine of theta equals negative radical 39 over 8. Okay, now I need to, second part of my question says find tangent. Class, which trig identity has both tangent, cosine, and sine? Put your finger on it. Class, which identity is it? The quotient identity. Now you've noticed a little clue that I've been doing. I'm writing down which family or which identity I'm using it from. Pythagorean, quotient, or reciprocal identities so far. You're eventually going to have like 10 of them. And you're kind of just putting your finger like which family is it from. You need to think about the relationships. So I have tangent of theta equals sine of theta over cosine of theta. Well, in orange, I have 5/8. I just found my sine value down here. And we're just trying to find tangent. So sine is negative radical 39 over 8 divided by cosine, which is 5/8. So I have a fraction divided by a fraction. I like to turn them sideways. Class, what happens to this math operation? So I have negative radical 39 over 8 times 8 over 5. I notice that my 8's cancel, and tangent of theta is negative 39 over 5. I'm going to double check my answer. I know that we're in theta is in quadrant 4, so only cosine and secant should be positive. That means all my other ones are going to be negative. Now, definitely double check this. This was a #1 mistake of students missing this problem. They get stuck between, they're not sure if it's positive or negative. Go back to where you know they're positive.